Technical session number 21. We're talking about our network servers, all those fun little things that do all those special things that we want in our life. Web servers, email servers, print servers, file servers. There's so many. We're going to be able to distinguish between the different server types in a network and explain how IT professionals might use knowledge of network servers to support their clients and describe the role of security network appliances and common safety procedures associated with them. BSMs we want to take into account for this particular technical session: customer focus, because they're the reason we're here. We don't have them, we don't have us. All part of the deal. So the better your customer service is, the more valuable you will be to your team, and the more likelihood you will continue to move up that ladder. It's not just the technical skills, but the soft skills that help distinguish us from our peers. Persistence. Keep pursuing the answers, even after you may have turned them over. The problem's over to someone else. All right. This one. Let's see here. Jimmy, can you read for us, please? Are you not in a place where you can read?
He's at the vet.
He's at the vet?
Oh yeah, he stepped away.
Yeah.
I think he's listening to.
Okay, okay. That's fine.
Listening. I'm at that currently.
That's fine. That's fine. I forgot.
Thanks.
Romario, can you please read for us, sir?
No problem. How will knowledge of service impact your IT career? A computer technician is a professional who repairs and maintains computers, networks, and servers. The technician's responsibilities with servers may include building or configuring new hardware, installing and updating software packages, and connecting to networks. Understanding different server roles is the first step in order to later configure and manage servers in more senior positions.
There you go. So first we need to understand what they do before we can understand how to interact with them. Kind of like all the brain dump we've been doing for the last couple of weeks. We've been giving everybody a base knowledge, definitional understanding as to what things are and how they interact, so that when we start putting our hands on them in labs and in the real world, we understand how these things interact and we can better handle any issues we foresee with them. All right, server roles overview. Here are 8 basic types of servers that you will see in the most common settings. You have your web, file, print servers, DHCP, which we should know what that one does, right? What does DHCP do again?
Sign IPs.
Sign IPs, very good. Let me get the DNS. What does DNS do?
Convert names to IP addresses.
There we go. Names, IP
Nice job.
addresses, and back. Who wants to take a stab at what a web server does? I promise you they're not trying to trick you.
Host websites.
Host websites. Okay. File servers. What might we do with a file server?
File servers are databases.
Databases, restore files. Gets more complicated as we go. What about a print server? It's not trying to trick you.
Manage all the printer jobs
Manage
of
printers.
the network.
There we go. Go to mail server. Questions aren't going away. They're going to keep coming. Be right over the mute button or ready to click. Manage emails. Thank you, Renee. Mail server manages emails. So that leaves us with two left. Authentication servers. When we hear authentication, what does that make us think of?
Security.
Security. Am I allowed to be here? Am I authorized? Authentication server basically verifies that you have the proper security clearance to be able to see whatever it is behind those firewalls. So authentication. Now we get to proxy. That's a fun word, proxy. Anybody know
Is
what
it like security too?
Kinda. It can be used for security.
Is it for like it manages like connections between the internet and a user?
Yes, it can be used for that. Absolutely. Does anybody understand what a proxy war is? Outside of IT, a proxy war. Basically, two larger countries can have conflict with each other by using smaller countries. So they're using those other countries to work on behalf of them. Proxy servers kind of do the same thing. They're operating on behalf of you. So as an IT person, you don't necessarily want to expose your internal systems to, you know, external vulnerabilities. So instead of the individual user being able to directly request information from a website, it may directly connect to a proxy server, and then that server will make the request from the external website, and then that information will come back through. You can use that for things like content filtering, like I don't want people to go to gambling sites or what have you. But it also can be used kind of as a security measure as well for external people trying to access internal documents or findings. So also hackers can you have a clever use of proxy servers to make you think that you have direct connections to the internet or banks or something like that, but you're actually going through their systems so that they can essentially glean or siphon off data like bank account numbers, things like that. So
Your mother's maiden name.
there you go. Yeah, get you know, personal information from you so that, you know, they can use those to either set up accounts or access accounts that you already have. So that's what a proxy server is. So we're done. Good night.
Nice. See you guys tomorrow.
So, all right. A little bit more into it, but that's basically what it comes down to. Web servers themselves. Purpose, response to requests being made by browsers utilizing HTTP and HTTPS, which are located on which ports? If we answer the questions, this goes a lot quicker.
HTTP is 80, HTTPS is 443.
There we go, 80 and
Nice.
443. Thank you, on the spot. They can be contained within a network and only be available on that network if you wish to set them up that way. They do this in some larger organizations, or they can be accessed by external hubs or hosts in the case of like Amazon or what have you, where other people are going to be coming to utilize your services. Most commonly, they can provide access to information and resources as well as allow for things like shopping, all kinds of fun stuff like that. You can either store these websites statically or dynamically, statically where they do not change. It's basically just a page for information, or dynamically where they are constantly changing and being updated. File servers, stores documents, videos, images, anything a user may want to save for later. Main protocols used would be the SMB, server message block, or the AFP, Apple filing protocol for Apple. So those are the two main protocols used by those. In enterprise settings, companies may want to set up essentially share drives where everybody has access to these drives for large stores of, knowledge or information or what have you. So everybody stores the share drives, and then if you need files, you go to the share drives and you pull them out. Some companies may not allow you to save to your local drive on your computer. Everything will have to be stored on the shared drive. So there are security reasons for that, but that may also be the case. And they also may deny you any permissions to be able to delete any files. You can save files there, you can add files there, but you cannot remove any files. So that is something that they may establish as well. And the definition of a domain is a group of computers and devices that are administered as a unit with common rules and procedures and are defined by sharing common part of an IP address. So it would be like that part of the network address. Questions? Print servers. What's a read for me here? TJ, can you read?
Yeah, the purpose is a dedicated computer or software inside a computer used to manage one printer or multiple printers. It provides the spooler service to the printers. Many enterprise printers come with a built-in print server, which makes using a dedicated machine for the role unnecessary. The connections, the server might be connected to a computer, then added as a network device or the network adapter, and the use of software is built into the printer through an adapter card. And then the protocols, the print servers use standard printing protocols, the SMB, the server message block, the IPP, the internet printing protocol, and the LPD, the line printer daemon.
Thank you.
Yeah.
We will revisit these when we talk about printers. So yeah, there are two basic types of printer servers. You can have basically a dedicated computer that is literally just sitting there, hooked up to the printer itself and kind of sharing that printer for everybody else. Small offices, it may just be like one of the main computers in the office that somebody else is using, also doubles as a print server. And then you have higher end, enterprise printers will actually have the circuit board and printer spooler or network printer server information already built into it. And all you have to do is hook it up to the network, and then you can kind of get everybody hooked up to it at that point. All right. DHCP, we should all be pretty familiar with this one by this point. It automates the process of offering up IPs to everybody. And it gives the following information to every host when they come on: IP address, subnet mask, default gateway, and DNS server. Those are the four key pieces of information you need when you hook up to any DHCP server. The DHCP servers, they're used in multiple environments. We do use them in our homes, we use them in offices and things like that. And they can serve a multitude of functions. DNS, domain name server. All right. Evan, can you please read for us?
DNS servers. Servers that resolves device and domain names, website names to IP addresses and vice versa. Client configuration. Clients are configured with the IP address of two DNS servers, usually through DHCP, and makes requests of the server using what are called queries. The organization's DNS servers will be configured to perform the lookup of IP addresses of which it has no entry in its database by making requests of the DNS servers on the internet.
All right. So it serves the wonderful purpose of just really helps when I'm muted. So it serves the wonderful purpose of changing IPs to FQDNs and back, because the internet itself does not understand the FQDN. It only understands the IP. FQDN is for us, for the most part, being able to understand what is put in, and it's easier for us to remember. Right, proxies. Let's see here, Ramsey. You read for us, please.
Proxy servers purpose: server that makes internet connections on behalf of users. Network benefits: prevents users from making direct connections to the internet and provides a point of exit which you can control their access in a variety of ways. A company large enough to use a proxy server uses it as an intermediate server as follows. 1. Client makes the request to the proxy. 2. The proxy performs the actual request. 3. The proxy provides results back to the client. This is useful due to the overall control of access, caching, URL scanning, and content scanning, assuring that all access is done with high security.
Excellent. Thank you. So essentially it operates as an intermediate, kind of working as security, but also as a content filter. All right. Moving right along. Mail servers. Pretty straightforward. Luis.
Purpose of mail servers. Servers that run email server software and use SMTP to send and receive email on behalf of users who possess mailboxes on the server. Client configuration. Those users will use a client email protocol to retrieve their email from the server. Two of the most common are POP3, which is a retrieve-only protocol, and IMAP4, which has more functionality and can be used to manage the email on the server. Management, usually managed by either an ISP or an internally in an organization where the IT department is responsible to keep the mail server running 24/7.
Very good. More often than not, this is farmed out nowadays to somebody like Microsoft or Amazon or something like that, where you have them manage your mail servers. But in large organizations, they may not have that trust factor with regards to that, and they may go ahead and set up their own homegrown systems. It's not overly complicated, but maybe something that they prefer to do just for increased security. Authentication. Here. Fidel, can you please read for us?
Hello.
Yep, we can hear you, sir.
All right. Purpose: server that accepts and verifies the credential of users. Typically, it not only authenticates them, but also provides them with access to resources using single sign-on. For example, Windows Active Directory. Single sign-on allows the user to authenticate once and not be required to authenticate again to access the resources to which they have been given access. When to use, this is not required on a small business or home network, but is almost always on an enterprise service. When an employee needs to have access to a certain set of files, this server will use a set of redundant servers to authenticate the user's credentials, allowing access.
There you go. Single sign-on, or SSO, being utilized through authentication servers, because if you've ever been in an office environment where you have to use a multitude of different programs, you have to have individual sign-ons for each one of those programs, and the passwords expire and change at different rates, you can go through password exhaustion for the most part and forget which passwords go with which programs. This kind of helps get around that. Once you have put in your primary authentication on that system, it grants you authentication through everything else. So it is kind of a nice feature. We kind of have something similar to that for ourselves. Like if we use things like keychain or password managers and stuff like that, that essentially operates kind of like a single sign-on where you're authenticating to the password manager, and then they will authenticate everything else for you. So very good. I'm not sure what you're doing. Here we go. All right. Network servers security. We do talk about it quite a bit in this class. Security absolutely is vital when utilizing network services or data that is stored on your servers, or when you are manipulating or working with the settings on your servers. If you were going to be logging into a server, you should at minimum use Secure Shell, which is a cryptographic network protocol for secure data communication. So it'll allow you to log in and manipulate the servers. You would utilize a remote command line login, and all the commands you will be executing will be through command line, not a GUI interface when working with servers. Secure network connectivity through your VPN. So you would utilize a VPN to encrypt your transmission, Secure Shell for your interactions within it. So you're essentially creating a layered security protocol. And as we know, VPN can create a secure connection between 2 points over an insecure network through a encrypted tunnel. All right. On our network, some of the main security appliances, physical appliances you would likely use would be these 4 basic types. You would have your firewall, which we have briefly talked about, that uses access control lists to determine who can come through and who can't. And it could be either a stateful or stateless firewall. Now we need to talk about intrusion detection systems and intrusion prevention systems and a UTM. What exactly is a UTM? So firewalls can be either software or hardware. Hardware is the most robust security. Software is not as secure, but you can create a layered approach. Now you might have if you have software firewalls, they would need to be on every single system, where hardware firewalls would protect the edges of your network, as well as in between less and more secure areas if you so chose. And we talked about stateful and stateless, where you have the stateful, which pays attention to the state of the conversation. If you initiate the conversation into the exterior, it assumes that you're expecting that exterior host to reply. So it allows that conversation to continue. So that is stateful, less secure than stateless, which is a packet filtering firewall, which is going to examine every single packet that goes through the firewall itself to make sure it should be able to go through, and making sure which protocols are being accessed. So with that, that is where the access control list would come into play. You can either whitelist systems where certain things are allowed, anything that is not on that list is auto denied, or you could blacklist things where if it's not on that list, anything on that list will be blocked, anything that's not on that list will be permitted. So it's the two types of lists you would use with your ACLs. Right. Intrusion detection system. This also has a software and a hardware component. So they can either be software or hardware. And it is responsible for monitoring the network itself and looking for anomalies, unauthorized access, or attacks, spikes in resources. So it can alert the IT department as to what issues have occurred. It can verify, itemize, characterize threats from outside or inside the network itself. They're usually programmed to react in very specific ways through, or in very specific situations. Most likely though, it's just going to send an email or a text to whoever needs to be notified saying, hey, an attack is underway. It just detects the attack. So you can have it on the individual system where it's called a HIDS, H-I-D-S, or host intrusion detection system. And that is when it is software installed on each individual component. Then you would have your network base, which would be out of line, kind of monitoring all the traffic on the network. And that would be a NIDS, or network intrusion detection system. It monitors the network traffic, local segments, and you can configure a NIC on a computer. So you can set up a computer to be a NIDS, and you set the NIC on that computer to what's called promiscuous mode, which means every signal that gets transmitted on that line, it just lets it in. So that is one way to essentially create a NIDS on a network. All right, question on HIDS and NIDS. All right, on to HIPs and NIPs. We got intrusion prevention system. Now, first we talked about intrusion detection, where it just basically goes, yo, you're under attack. It doesn't do anything. It just basically just lets you know, hey, there's a problem. IPS is a step above that, where it actually takes action to prevent malicious attacks. It scans the traffic on the network for signs of activity and can take some action to prevent it. It can cut off that line of communication. HIPs and NIPs need to be in line, meaning you can't just have it on the edge of the network monitoring all network traffic. It needs to be directly in line between, say, your device and the external network. And if it's sensing an attack, it can cut off that network connection right away. So that would be a NIPS, a network intrusion prevention system. HIPs would be on the system itself, and you would deploy that only on specific or strategic hosts to kind of monitor those. And these can use the IDS and IPS can use things like heuristic algorithms to detect anomalies. And heuristic basically is a fancy word for behavior. So if it detects odd behavior, it can shut those things down or notify somebody that there's a problem. So even if it's not a known threat, it's not identifiable by a definitions list as a known type of attack or known malicious software based on particular types of behavior. Like if web traffic spikes 5,000% in under a second, okay, there's a problem here, cut that off. We're probably dealing with a denial of service attack. Questions so far? So we are relatively comfortable with firewalls, HIDs, NIDs, HIPs, and NIPs. Just remember the H and the N stand for host and network. Host on the individual machine, network, it is a device in the network itself. And then detection versus prevention. Detection just lets you know, prevention takes action to stop it. Next, we have what's called a UTM, or Unified Threat Management. They are also known as web security gateways. This is essentially a device with a whole bunch of tools on it. Performs multiple security functions at the same time. It is a combination of network firewall, network intrusion prevention, gateway antivirus, anti-spam, VPN, content filtering, load balancing, data leak prevention, and on-appliance reporting, all in a singular device. Sounds pretty awesome, right? All in one, fantastic. I buy this and I can check out. I'm done. No more security. Don't need it. Problem is single point of failure. If this device fails, you are wide open. It does have its functions. You know, it's good for small businesses and stuff like that that can't afford to have multiple hardware firewalls and buy all kinds of fancy equipment. It does provide a relatively economic, well-rounded security function. But again, it gives you a single point of failure. Questions?
This is a piece of hardware, right? This is like
Yes, this is a piece of hardware. All right. That one went by pretty quickly. Now, after this, we should be able to distinguish between the different server types in a network. What were they? There were 8 of them. Let's go ahead and rattle them off while we're here.
File server.
File server. Here we go. Here's one.
Web server.
Web server.
Mail server.
Mail server.
Proxy server.
Proxy server.
Print server.
Print server.
Authentication server.
Authentication server. There we go.
DHCP.
DHCP. One left.
DNS.
DNS. That's all 8 right there. Beautiful part about the servers is the name pretty much tells you what it does. Only ones that might trip you up a little bit might be authentication and proxy. For the most part, what it tells you it does, that's what it does. You know, and then we should now be able to explain how IT professionals might use knowledge of networks and servers to support their clients, and describe the role of security network appliances and common safety procedures associated with them. What are our 4 security appliances?
UTM,
UTM, Unified Threat Management.
IDS,
IDS, Intrusion Detection.
IPS,
IPS, Intrusion Prevention.
firewall.
Firewall. There we go. Do you have a question, Umberto?
Yes. Does a server have a GUI or just are accessed by commands?
If you're remote accessing in, it's likely going to be command line only. If you're direct linking in, you could you could possibly have a GUI interface depending on the type of server you're dealing with.
Thank you.
No problem. Any other questions, comments, concerns? So I see some, you know, Avery is, you know, getting on us about the hairlines. And I know you look at me, you look at Marvin, you look at Professor Messer, you look at Mike Myers, you even look into generation, my teacher, John Downs, and Marvin's teacher, Chris Rick. And you're sitting there wondering to yourself, is it required to have a close cut haircut and either a beard or a goatee in IT? Yes, it is part of the dress code for men. Tattoos are optional. We give Avery a pass just because he's still in training.
Yep.
I see, you know, along the way, we got, you know, Romario, Mark. There's a lot in here that are already kind of embracing the, you know, the look. Those of you who are, you know, trying to grow your hair out a little longer.
Probably won't
Just
make
to-
it in
just
the
to say.
field.
Women's hair, it has to be multicolored. And
I'm sure we can rock a goatee too if we want to.
We respect the commitment.
respect the commitment. All righty.